Alright, this will be a quick tute on symbol customization using values in the layers attribute table. The data set we're using here is a data set of weeds. The fields we're looking at are size and density. The size is recorded in meters, as you can see here, and the density has a value which represents a percentage. It's not a like for, you have to estimate. So at the moment all of our points are rendered the same size. That's default for a simple symbol. Density starts at about 1 usually. Here it's 2 and goes up to 6. 6 being no data recorded or not known. First we want to tackle the size. At the moment the symbols aren't showing us much about the data. They're just points and they're all the same. You know, a diameter can be as low as 5 and it can go up to 100 in this data set. So let's see how we change that. We go to the Layer Styling tab. Now we want to change the size. So there's a size option. At the moment they're all rendered at the same size. We want to change it to meters at scale so that they will change with the zoom level, and they'll actually physically depict the size of the infestation. At the moment every point is at 2 meters. We can make them all bigger or we can make them all smaller. We want them to change with the data, so we have to create an expression. So we go down to Edit, and this is just a straight value off the table. So we go down to Fields and we find our value that we want to use, which is size dia M. We just double click that and it puts it into the expression. And you can see down the bottom where it has preview, it tells us what value we're going to get for different features. That's doing what we want it to do. So once we're happy we go OK, and then you can see if we zoom out the data points have all changed size, and we can verify that by going in and checking some. So here we have one we're going to measure. Tells us that it's 98, which, not being a precise measurement, that one you can be sure that the data point is saying 100 and that would be 100 meters. There we go, size diam 100. So it's doing what we want it to. Okay, so we're happy with that. I'm not happy with the color though. So there's a couple of, and the reason for that is that color can also be used to depict things. We want color as a quick way to identify which data points haven't got a density recorded. So we're going to go back to the Layer Styling tab. So let's have a look at a way to do that. Okay, so fill color. At the moment it's blue. We're going to just put in an expression, so we select Edit. Now I've already put together a user expression for this because it would take a bit of time, which we don't have. Color by density. I just double click that and you can see this expression is based on the field value denscat, and so when denscat equals 1, then grey, denscat equals 6, then brown, etc. You can see you can use plain English, or you can also use I think hexadecimal, is it hexadecimal? Codes, basically color codes such as this. You can pick any color you like as long as you know the code. That's a code for essentially green. So we got to the expression we want, we go OK, and you can see most of them are green, but occasionally there's a brown one. Now these are the ones that represent they don't have a density cat value of 6, which means density not recorded. So the colour's working well. Now we can easily identify points that don't have a density. The other thing we wanted to do was also shade. So though all those green ones where we have data, we also want to be able to easily identify where the dense points are and where the not so dense points are. So for that, we're going to need to create another marker on top, which will go on top of the current marker. So go back to layer styling, and we're going to, there's two ways to get to layer styling. You can double click on the layer. I don't like to use this particular method because whatever changes you make in here, you don't see until you apply it. So we'll close that one. We'll go back to layer styling. Whatever changes you make here are automatically updated. Now we want to add another marker. So go up here, we add the marker. It sits on top. At the moment, it's not the right size. We need to get it to the right size. And we also want a filled marker this time. We don't want a simple marker. So at the moment, that's too small. So we've got to go to meters at scale so that it will change the same. But I'm putting in the size diameter value first. So now they're too big because we haven't changed the millimeters in the size. So there we go, we fixed that. Now you can see both our markers are the same size. Now instead of simple fill, basically we've got two colours over each other, we want a line fill. Now you can see that it's sort of how it's rendered one on top of the other. To make the shading effect better, we'll change that line to a black. So we can just go into line and change the colour. Now, it's still not quite what we want because they're all spaced the same. We need closer lines together when our value represents more dense. So spacing, again we want meters at scale. We want it to scale as we zoom in and out. Now we need an expression so that it responds to the density value. So we go down to fields again. Well, actually we don't. We go down to user expressions because, and we'll get there, I've just taken my time, a little bit confused. We want to use that value, but we need it to be a little bit more sophisticated. So we go down to user expressions and logarithmic shading. So this is it took me a while to figure this one out, but basically we've got a value for, or a spacing. These all these equations give a different figure for spacing of the line dependent on the dens cat value. Now, I can't explain all of that in the time we got now. If you have any questions about it, feel free to ask. Essentially it's a log scale, which just, it turned out it fit my purpose as well. So we'll apply that. Whenever you do a lot of work on an expression, it's a good idea to save it. And you can see over on the right there where the expression is, there's also some pointers about how it's used. So now we've applied it, you can see we have some darker points and some lighter points. The lines are, and that effect is just because the lines are either further apart or closer together. We can just verify what's going on by looking at the detail in some points. So here's one that's quite dark, density cat 5. So that's the densest value you can get. And look at this one, it's a little bit lighter. You can see that's 4. And this one here is lighter again. So if we click on that, we can see it's density category 3. So that's essentially how it works. We now have a very easy way to eyeball which points are denser than others, and that works at a lot of zoom levels, which is handy. Now you may also want to add a label, and those are customizable as well. So here, if you just choose the label tab, go for a single label. I've already prepared something here. This is a little equation or expression, sorry, that joins together a number of fields. So we use the concat tool. Basically, whatever you put in the brackets will be joined together. So we've got the diameter, then we've got some text. The stuff in quotes there is text. So we've got M and then /N. Now the /N means new line, so that's like a carriage return. You can see we have 2 lines on our label. So we've got 50M and then D5, which is basically your density value is 5. So we go OK. Now we can't see it, it hasn't appeared yet, and the reason for that is that I haven't turned, I've got scale dependent visibility turned on. The reason for that is when you're zoomed out, you don't want all those labels making a mess of your symbols. So if we set scale dependent visibility, labels are turned off when zoomed out, but when we zoom in closer and we want to have more detail on the information, we can have that as well. So I've set that at 1 to 4,000. If we quickly zoom in, so now we're at 1 to 2,500, you can see all our information there that we want on our label is also depicted. So you don't have to guess what the density is just by the representation in the symbol. You can know. So it's useful for that. And that's it. Thank you.